Hey guys, welcome. I am going to go over all the writing prompts. Nothing I'm saying here you probably couldn't figure out for yourself, but I'm going to go over them because I feel like a lot of kids are having questions, not understanding the writing prompts, and it's probably because they're just not reading them. And so I want to go over them with you. Okay, so what I have in front of you is the survival guide. This is like the most important possible thing. If you don't know what is going on, there's nothing really I've said that isn't in here. Okay, so if you scroll through this, maybe you printed it out. The algorithms is a good algorithm. We made a video, we did all of these problems. Okay, the next part, abstraction, is a good abstraction. We made a video for that, separate video, went through all these problems. Okay, so if you don't know about those are probably the most important. Narrowing it down is just a way to help you figure out what game are you going to make, or what project are you going to make. It gives you some example projects. Not that big. And then putting it all together, it's just helping you brainstorm what ideas you want to get down. We're going to skip that. Okay. This right here is a progress checker. What's your program's purpose? What are you going to show in your video? The development process. That's what we're talking about. That difficulty or opportunity that you could have. You should have two of them. Identify your main algorithm. The name of the function. Remember, it has to be a function. Where is it in the code? What does it do? Explain the mathematical or logical concepts. How does it relate? This right here actually outlines your writing prompts. 2A is the first writing prompt, 2B, 2C, and 2D. This is outlining what your writing prompt is on. So I would actually start here and start filling this out, because it asks you very simple, easy questions that will help you prepare for the writing prompt. So this would be the first place I would start. Fill this out, print it out, or if you can't print it out, just on a piece of paper, make your own version of it. Okay? Alright. Then there's the completion timeline. This is basically what I'm using to let you guys know what we need to get done. So that's how you can see what's happening. But this is the most important part of this whole document, is starting right here. And this is the guidelines for each one. Okay? So I'm going to go over each one of these. So buckle in. It's going to be a little bit of a long ride. You can skip part through each one. So here we go. So first thing is you have to make a video. I created a video on how you can make your video, so go watch that. And so prompt 2A is a written response or audio narration in your video. I always say go for the written response, don't do the audio, because when you talk, you usually talk too much. Okay, this is the easiest prompt to write though. All you're doing is identifying the programming language, which everyone it's going to be JavaScript, because that's what we're using. Identify the purpose of your program. What is your program meant to do? That is up to you. And explain what the video illustrates. So what are you doing in your video? Okay, so don't just jump in your video. Have a kind of a purpose for your video. When you do it, it can only be less than a minute, but it should be pretty easy. Alright? Advice. I love that they give you this part, advice, on what best you can do. Okay? The video needs to run continuously, so no stopping or pausing. Okay, run continuously. Shows one feature. Program does not need to be complete as long as you demonstrate the one major feature that you're running. Describe the purpose. So this is going to be in the written part. The purpose of the program is intended goal or objective of the program. In other words, it's the what the program is supposed to do. Why did you make this program? Is it for fun? Is it for something else? Is it a game? What is it? And if it is a game, what kind of game is it? Okay, and then connection to video. Make sure that you can connect the purpose of your program to what you're showing. So if your program's purpose is to, calculate, I heard one person making a game where they were like ordering food, and it was going to calculate how many calories it has or something like that. Well, then you should say what the purpose of it is, and it should be matching what you're showing in the video. Okay? Checklist. Oh, my favorite part. If this was me, I'd print this out, and as soon as I do things, I'd just check them off, because I love checking things off. Video runs continuously. Check. Less than 60 seconds, less than 30 megabytes, check. If you follow my video, you'll have no problem with that. Video demonstrates one feature, check. Written response. Identifies the programming language. First sentence, I use JavaScript. Everybody use that. Identify the purpose. My program does this. Describe the features. In my video, I did this. May also be audio commentary in your video. Don't do that one. Just cut that one out. Okay? and connect what you do in your, featured in your video and how it connects to the purpose of your program. Okay? Easy, does not exceed 150 words. That doesn't mean you can't exceed, but this is a general guideline. You should only have about 150 words. Very short. All right, prompt 2B. So this is what I've been asking you guys to think about this week. Describe the incremental and iterative development process. That means the slow process of making your program, and iterative meaning going back and fixing it and making it better, right? Incremental, we're slowly moving up, and then iterative, we're going back and looking at it and say, hey, how can I make this better? Focusing on 2 distinct points in that process. Okay, so describe the difficulty or opportunity you encountered and how they were resolved or incorporated. In your description, clearly indicate whether the development described was collaborative or independent. Most of this is going to be independent because we're not in class, so you can't really collaborate with anyone. Maybe you are getting on the phone being like, hey, how do I do this? I'm not sure. Could someone help me out? At least one of these points must be independent. So it says 2 distinct points. Okay? So here's some advice. There are many individual pieces of information you need to fit into this response. Use the checklist at the bottom carefully to make sure you don't miss any. Here are the most important things to remember. Don't forget the overall process. Okay? You should reference your development process as a whole, not just 2 points in time. This is good. Your response should reflect an iterative process of identifying and solving problems, focusing on problem decisions, i.e., writing a function to display a score, versus design decisions, how to lay out a screen. Okay? So think about how it's doing overall, it's going to do it. Okay? Difficulty opportunities. You need to describe 2 distinct difficulties, opportunities. So you could do 2 difficulties, 2 opportunities, 1 of each, doesn't matter. So difficulty is likely either a bug in your code or a difficult design problem you needed to work out. So maybe you had this great idea that you wanted to create a program that was going, I know one kid wanted to do Connect 4, and you want to make a Connect 4 game. And so maybe the difficulty there is, how do I program the computer to know where to drop the next one? Okay? And then how'd you work through that? An opportunity is likely an idea or realization that you had developing your code that led to a new idea. So that could be an example of a trivia game where every time you get one right, it updates the score. And so you realize, it would be a lot faster if I just made one function and recalled that function every screen, and that would make it a lot easier. So instead of rewriting the function each time. Okay. Feedback, testing, reflection. You should clearly describe how you identified the 2 difficulties or opportunities. Was it through testing your program out, personal reflection, or through feedback from a peer? So, how did you realize something went wrong? That would be for a difficulty. Or, how did you realize that this would be faster? So you want to say, I was testing my program out and I realized this. Or, I was thinking about it and this would be probably a faster way. So a lot of people are going to use personal reflection to think about an opportunity. Or feedback from a peer. If you're having someone else look at it, you can jump on a Google Hangout with someone and show your code if you like. Independent or collaborative. If you develop your program completely independently, you need to say so. Don't assume the reader will know. If you develop your program collaboratively, some parts need to be done on your own. For this percent, make sure. So clearly indicate which parts are done collaboratively and which ones are not. Most of them probably be independent. No identifying information in your response. It's okay. I worked with a partner on this part of the program. Don't say I worked with Jesse. So don't identify the person. Okay? Clearly state which of the difficulties or opportunities described here were done independently or on your own. Alright, so here's the checklist. Alright, so overall development, make sure you respond and describe the overall development, not just the 2 key points. So give an overall development overview and then go into your key points. The response indicates whether you completed the project independently or with a partner. Again, this is probably going to be independent. So, first opportunity or difficulty, the response describes one difficulty encountered early in the development versus one later in the development. So you want one in the beginning, one in the end. Okay, so it could be, again, an opportunity that you learned in the beginning, maybe a difficulty in the end where you had to fix some things. The response describes a difficulty, so it could be one of those two. The source of the difficulty opportunity, so feedback, testing. So what did you encounter? How did you realize that you were going to encounter that? And then how did you solve it? So those are the 3 hits that you want to do. What was it that went wrong, or that you realized you could make better? How did you figure that out? Was it testing, feedback, reflection? And then what did you do to solve it? Or make amends, or not amends, but like use that opportunity. Okay. If first difficulty opportunity was not solved independently, then this one must be. So make sure at least one of them is independent. Most of them will be. All right. 2C. This is gonna be a long video, huh? 2C, then 2D, and we're done. Pretty much. Okay. 2C. Capture and paste a program code segment that implements an algorithm marked with an oval in section 3 below. So you're going to do that in section 3 where you're going to mark your code. And we'll have a video on that too. So, capture and paste a program segment that implements an algorithm and that is fundamental for your program to achieve its intended purpose. This code segment must be an algorithm you developed individually on your own. You must include 2 or more algorithms and must integrate mathematical or logical concepts. Describe how each algorithm within your selected algorithm functions independently as well as in combination with others to form a new algorithm that helps to achieve the intended purpose of the program. So this is, if you're focused on what's a good algorithm, that video is basically this section here, 2C. And that's what it says right here. Review, is it a good algorithm? Okay? And for lots of helpful tips on how to use one. So we have a whole video on that. Okay, you wrote it. You need to have a written code of your algorithm entirely on your own, not with a partner, so make sure you wrote it. Copy and paste. You must paste your actual algorithm code as a part of this response, so you actually need your algorithm in this response to C. A parent and 2 children. Your selected algorithm, the parent needs to have 2 included algorithms, the children. Okay, so example 4 and 5 from the algorithm video. Basically, it's kind of like if you were to say, we did it a lot when we were doing the drawing program, programming with the turtle programming. So if you said draw scene as your main parent function, but within the baby function it was like draw pond was another function, and a different function would be like draw fish or something like that. Okay, so those would be 2 ones that they could work independently. You could draw fish by itself, you could draw pond by itself, but you put them together and then you have draw scene, and it's a pond with fish. Very simple explanation, but you get it. You have to include at least one of the algorithms needs to have a mathematical or logical concept. So that means we're looking for some sort of evaluator, plus, minus, greater than, less than, equal to type thing in there. Break into functions. To make it easier to refer to individual parts of your algorithm, give the selected and included algorithms their own function. Example, algorithm 4 is written in this way, so you can look at that one, but mainly it's name your functions, that way you can call them really easily. Then describe how, not just what. Okay, so you need to talk about how your code works, not just what the user will see when it runs. Do this by referring to the actual variable names, programming constructs, strings, and so on that are visible in your code snippet. For example, so here's one. The algorithm I selected in sign-in user, which handles the user login process in my app, which has 2 key parts, check name and start home screen. Check name has an if statement that checks to see whether the name enter is the username text to equal. So see how it's explaining what it's doing and why it's doing it, versus just this is the user sign in so they can sign in. Moving on. So they're explaining how they're using it by using the if-then statement. Okay, so checklist, a little bit long, but here we go. You wrote all the algorithm yourself. You copy and pasted versions of your code for the main and sub-algorithms with ovals around them. I'm going to show you how to do that in a separate video. The response identifies the selected algorithm parent and at least 2 included algorithm children. So basically there should be 3 functions you wrote. 1 big function with at least 2 functions embedded in them. Included algorithm 1 clearly identify the code for the algorithm, where in the code function name line numbers explain what the algorithm does independently. My algorithm draws fish. Describe how the code of the algorithm works. It makes a fish. Or how it uses mathematical or logical concepts. Both of them don't have to use it. And then this is the same thing for the next one. And then the selected algorithm. Clearly identify the code for the selected algorithm. Here we're talking about the main parent one, the one that is involving all of them. So this would be the function scene. And then the baby ones are the included algorithms. So it would be pond and fish for my example. Clearly identify the code for the selected algorithm, where in the code, function name, line number, describe how selected algorithm combines the included ones, why does it need those to function, and explain how. So the keywords here, how and how to achieve it. Alright, 2D, the last one. Capture and paste a program code segment that contains an abstraction you developed individually on your own, marked with a rectangle. Again, this is all going to be posted in section 3. This abstraction must integrate mathematical and logical concepts. Explain how your abstraction helps manage the complexity of your program. Okay. A lot of these say must not exceed 200. The last one I forgot. I didn't write that one, but it was do not exceed 200. So it's not. It doesn't have to be a lot of writing here. Think about it. We are a technical profession. We are not English. We are not language arts. We want precise, quickly. Don't fill it with fluff. Okay. So 2D advice. Go back to the is it a good abstraction? So rewatch that video on how you can pick a good abstraction. So choose a function. Unless you feel confident about another abstraction, choose a function, not an on event. So remember, no on events. You wrote it. Copy and paste it. Okay. Manage complexity. Make sure you can describe how your abstraction manages complexity in your program. That's like the keyword. Why is this making your program better? Make a contrasting argument. Explain how your program would be more complex to read, write, or reason about if you didn't create it. Okay, so this could be that thing I was talking about. I wrote a thing to update score because I have to use it so many times. If I had to rewrite that code for each trivia question I did, then my program code would be so much longer to write, so much longer to read, so this makes everything a lot faster, manages the complexity. Mathematical and logical concepts, while you should aim to include these in your abstraction, this is not explicitly assessed by scoring guidelines. So it'd be nice to have them, but maybe you don't need them. So here's your checklist. You wrote all abstraction code yourself, no event on events, make sure it's a function you defined and named. Response includes a copy-pasted version of the code with a rectangle around it. So oval around your algorithms, rectangle around your abstraction. Response identifies the abstraction by name. Okay, so this is the function that I'm using to express. So my function is update score or whatever. You explicitly describe how the abstraction manages complexity by explaining how your code would be more complex to write or reason without the abstraction. Okay? Again, go back to the abstraction video. It's a good one. Alright, last one, part 3, program code. So this is where you're going to capture and paste your entire program code. Okay, so mark with an oval around the segment of program code that implements your algorithm that you created for your program that integrates other algorithms and integrates mathematical or logical. So oval around the algorithm, rectangle around the abstraction, and include comments or acknowledgments for program that was written by someone else. I'm assuming this probably won't happen. So I'm going to make a video on how to do this, making the PDF of your code using this thing called code print. So I'll make a video about that and how to mark these things. So that's pretty easy. And then citing images. If you use code or images that was made by someone else, for example, you found online, then you should cite those here as well. So you can cite whatever it is. They do it really easy. Just number what it was called, like whatever it looks like, and then just the web page that you got it from. Okay, that's it. Fairly simple. Maybe not. If you have questions, let me know.